Good morning. All right, one person is not tardy. It's 8 a.m. and there's one person who's not tardy. I seem to have the hardest time waking up on Thursday this school year so far, by far. Waiting for a couple more viewers to show up before I get started. Hello, good morning. I can't stop. You know how sometimes you see someone else yawn and then you yawn yourself. Well, when I yawn, in reality, my live stream is delayed by like 20 seconds. So I keep seeing myself yawn like 20 seconds later. And then I make myself yawn again, and this cycle repeats. So I'm on like a feedback loop of yawning with myself. We'll wait like 30 seconds more before I get started. Okay. Hello, good morning, everybody. For the SL class this morning, we're going to be learning about hang on, I needed to pull up a tab for later on. For the SL class, we're going to be learning about what's called inheritance, class inheritance this morning. And for the HL students, we're going to be learning about what's called a different data structure called a queue, Q-U-E-U-E. All right, so I'm going to get started. And we're going to start off with the document camera. Okay. And so I'm going to represent two classes as boxes. Okay. So we've got two classes. And I'm going to connect them with an arrow that goes upward. Okay. So the top box has what's called the Superclass. Superclass. I think I need to turn the light on so you can see a little bit better. Let's see. Autofocus for me. Maybe that's a little bit better. Okay. So there's the superclass, and then there is the subclass. So the subclass, we would say, inherits from the superclass. Okay? So when a subclass inherits from a superclass, it automatically gets all the fields and methods of the super. Okay? So it already gets all the field methods that are defined for the superclass, and then all you have to do with your subclass is basically write code for the additional fields and methods. Okay? So the reason that inheritance is useful is you can have several different subclasses that all, so maybe subclass 2, that all inherit from the same superclass. Okay? And so all of these subclasses are going to have the same methods. If you didn't have the superclass, you would have to redefine those methods for each subclass. And so your code would be very repetitive. You'd be doing a lot of copying and pasting and putting the same method into all of the subclasses. So, for example, like a toString, okay? Many classes have a toString method, okay? So you would put toString and define it in the superclass, and then you don't have to define it in any of the subclasses, all right? So it saves a lot of code. It's you don't have to copy and paste code. You just inherit. So it's kind of an elegant way to avoid rewriting code. Another way you can think about the superclass, sometimes it's called the parent class. And then the subclass is called the child class. Okay? One thing I wanted to show you. So there is a class. Oh, and by the way, you can have classes that inherit from a subclass. So this is kind of like a sub-subclass. Or maybe you want to call it a grandchild class. I don't know. So you can just keep going, and you have a hierarchy of inheritance. Now, with okay, now I'm going to go to. Now, actually, there is automatically. So, sort of like the granddaddy of all classes in Java, if you will, is the object class. So even if you don't say it, all classes inherit from object. All right? All classes inherit from the object class. So every class has these methods that are listed. Okay? Even if you never knew that, they all have these methods. So anyways, that's the base class in Java from which everything inherits. Okay. So yeah, if you have multiple levels, that's called hierarchical inheritance. Some programming languages allow you to inherit from 2 superclasses or more. So you could have a subclass that gets, so here's super 1 and here's super 2, okay, and here's the sub. The sub inherits from both super 1 and super 2, so it gets all the fields and methods from super 1 and all the fields and methods from super 2. Or even if you had other classes, you could get all the fields and methods from 3 different classes. This type of structure is called multiple inheritance. And this is not in Java. Okay. Java does not do multiple inheritance. And the reason is that it simplifies things. What if Super 1 and Super 2 have a method that has the same name, and you inherit from Super 1 and Super 2? Then the subclass is going to be confused about which method are you referring to. Are you referring to the method from Super 1 or the method from Super 2? If each class can only inherit from one class directly, the one directly above it, that's called single inheritance. And so that's what we have in Java. Okay? So let me write out the inheritance structure that I'm going to show you today. This is a completely contrived example. I was not feeling very creative yesterday when I was writing the code for today's lesson. So this is not very creative, but we're just going to try our best. So we're going to have a superclass called animal. Okay? And then we are going to have a subclass called dog. And we're going to have a subclass called cat. And both of these are animals, so they both inherit from class animal. And then I'm going to have a class inherit from dog that is called Boston Terrier, because I have two Boston Terriers. Okay, so that is the class structure, the relation between all the classes that I'm going to be showing you guys in today's little code snippet. Okay, so let's take a look at what I wrote. Okay, so I'm here in code board. I have my class animal. So let's see what animal has. Animal has a string, which is the name of the animal. It has a double called weight, which is the weight of the animal in kilograms. Okay, so those are the fields for the animal class, the superclass. Then here I have the constructor for the animal class. So all it does is it takes in a string and a double, and it sets the name and weight equal to those numbers. Okay. And then I have a toString method, which says, hello, my name is name, and I weigh weight kilograms. Okay. And then I have these methods, which are, of course, accessor methods. So notice that I don't have any mutator methods. So if you know, type it into the live chat if you know what do we call a class that has no mutator methods. If you know the answer to that, type it into the live chat. Okay. So now let's look at the class dog. So dog, if you want dog to inherit from animal, you have to include this statement, extends animal. So when you do that, if you say extends another class, what you're doing is you're automatically including all the fields and methods of the animal class without having to write them. Okay? So the extend statement means dog inherits fields and methods from cat or from animal. Okay, so notice how I don't have to write name and weight for the dog class. All I have is an additional string called breed. Okay, then I have my constructor for the dog class, and notice that my constructor has an extra string, which I'm calling B for breed. Okay, now here's what I can what you do. In the first line of my constructor, I have called super. Okay, so super parentheses is the constructor of the superclass. So if we look at this, notice how I'm feeding the name and the weight into the super constructor. So what that's going to do is it's going to call the superclass's constructor, which is okay, and we can see that the name and the weight are going to get set. Okay, so that's how I set the name and the weight in the dog class. Okay, and then the extra string that's part of the dog's constructor is what breed is set to. Okay, I added an additional accessor method to get the breed. Okay, and you'll see that I have a toString method. Okay, and now here's something that's kind of interesting. I already created a toString method in the animal class. So why did I recreate it again? Because I wanted to add additional stuff in the toString. Okay, so this is called overloading. If you overwrite a method that is already present, so if you have a method that is already present in the superclass, you can override it and have only the most only the version of the method that is lowest in the class structure is going to be used. Okay, so I overloaded the toString method. So basically, if a dog object calls toString, it's going to automatically do this one instead of the animal version of toString. But if we look at the code for this, see how I called super.toString. So when you use super dot, that will call the method of the superclass. So I'm calling the super's version of toString, and then I'm adding on to it by saying I'm a breed doggo. Okay, I know it's stupid. And then down here I added a new method called bark, where it just prints to the terminal woof woof. Okay, so let's look to the cat class. So we can see that cat also extends animal. It also has a string, which is called breed. It has a constructor, which operates in basically the same way. It calls the super's constructor, and then it sets the additional field for the cat class. I have also overloaded the toString method. So it's going to call the super's toString, and then it's going to add on to that I'm a whatever breed kitty. Okay, I added the accessor method, and the cat also has the new method hiss, which prints sss to the terminal. Okay, let's look at the Boston Terrier class. Now, if we look at the superclass of Boston Terrier is dog. Okay, so I have Boston Terrier extends dog. All right. In the constructor for Boston Terrier, I called the Superclasses constructor, but I automatically put in Boston Terrier where the breed goes, okay? And then I added a new method, which is called fart, because Boston Terriers fart a lot, that prints out to the terminal, all right? So now let's see what I did in the main method. And I got to change some of this. All right. So what I have here in line 4, I have animal Dumbo equals new animal Dumbo with a weight of 300 kilograms. I have Boston Terrier Hazel, which is a new Boston Terrier named Hazel with a mass of 12 kilograms. I have a Boston Terrier named Bug, which is a new Boston Terrier named Bug that has a weight of 10 kilograms. I have a cat named Ivan that is a new cat object named Ivan that is the breed Russian Blue and has a mass of 5 kilograms. Okay? So I created 4 animals, four different animal objects. Then I called the Bug fart method. Then I call the Ivan hiss method. Then I call the Hazel bark method. Okay. And then I print out Dumbo's version of toString and Hazel's version of toString. Okay, so let's compile this and run it. All right, so basically lines 9 through 13 are the lines where we actually print something in the terminal. So you can see that the first method called is the fart method of Bug. So we can see that comes out first. Then Ivan hisses. Then Hazel barks. Woof woof. And then I print Dumbo's toString method. So see how it says, hello, my name is Dumbo, and I weigh 300 kilograms. So that was exactly what the toString of the animal class does. That's expressed right here. And then I have the Hazel toString. So remember, Hazel is a Boston Terrier object. Okay. Hazel is a Boston Terrier object. So Hazel's toString is a little bit different because it has the extra line, I'm a Boston Terrier doggo. Okay? So that's how that works. Now there are a couple of things that you can do that are kind of neat. All right? What if I decided to declare Bug as an animal? Because all dogs are animals, right? So I say Bug, an animal named Bug, called Bug, is a new Boston Terrier. Wouldn't you agree that a Boston Terrier is an animal? So this actually works. Okay, I compile it, but you can see I have a compiler error in line 9. Cannot find symbol bug.fart. Okay, so why is that? Well, see how I've declared Bug as an animal? Does the animal class have a fart method? No, it does not. Okay, so I can't use the fart method for Bug because I declared Bug as an animal, not as a Boston Terrier. So if I do that, it works just fine. You see how compilation is successful if I just don't use the fart method for Bug. All right. I could declare Hazel not as a Boston Terrier, but just as a dog if I wanted to. And that'll work because a Boston Terrier is a dog. And you can see that the compilation is successful. Why was the compilation successful here? See how Hazel uses the bark method? The bark method was not defined in the Boston Terrier class. It was defined in the dog class. So as long as I use the dog methods or the animal methods, I'm okay. All right. One other thing I wanted to show you. This is kind of cool. So how could I use Bug's fart method? Well, there's a thing called casting. So casting means to interpret an object as a different object. So how you cast, so right now Bug is declared as an animal, okay? But if I want to interpret Bug as a Boston Terrier, what you do is you put parentheses Boston Terrier in front of it. So now Bug is going to be interpreted as a Boston Terrier, which does have the fart method, so this should work. Oh, I think I have to put all this in parentheses so the compiler isn't confused. Yeah, okay. So I declared Bug as an animal, and then I cast Bug into a Boston Terrier, and then I called the fart method, okay? What if I tried to cast Ivan into a Boston Terrier? Well, that's going to give me an issue, right? Cat cannot be converted to Boston Terrier because a cat is on a different branch of the inheritance tree, okay? So, anyways, this is called inheritance. One thing that's kind of cool is let me clear this up a little bit. I could also declare Bug as an object. Remember, because all objects or all classes inherit from object. All right. So if I compile this, it works. As long as I only stick to calling the methods from the object class. So all I could do with Bug is call, clone equals finalize get class, all those methods. Okay. So that's my lesson for the SL students. So now I'm going to go to the HL students, and we're just going to have a very brief discussion about the class Q. Okay, so I'm going to go to the document camera. So there's a class called Q, and the class Q implements, or this is a data structure, okay, implements a FIFO or FIFO structure. So you might recall that the stack was a LIFO structure. So the last in is the first one to get popped, okay? A queue is just like a line at the grocery store where the first person to get into the line is the first person to check out at the grocery store, okay? So a queue is sort of a you can think about it as a line of objects. This is a queue of 3 objects. All right, and maybe this is the front, and this is the back. Okay, and a queue has a couple of important methods. Okay, it's got the peek method, which is going to returns the object at the front of the line. Returns the object at the front of the line without removing it. Without removing it. You've got the enqueue method, which adds another object to the back of the queue. So adds an object to the back of the queue. And then you have so the enqueue method has an argument, which is the object that you're going to add to the back. And then there's a dequeue method. Okay. So the dequeue method returns object at the front of the list, and then it does remove it from the queue. Okay, so for example, this one would go away, and then now the front is right here. So a queue is important. The assignment that you guys are going to start working on is simulating a router, which is essentially a queue. A router in your house, you probably have an internet router, and your router is receiving packets from your internet service provider. These packets are coming in at a high rate, and the router just figures out where those packets are going to go. Which computer in your house does each packet go to? If you're using the internet at the same time as a sibling or your parents, then there are lots of different packets coming into the router, and they're being sent to different places within the house depending on who requested that packet. So a router is essentially a queue of packets, and it can receive a packet from the internet service provider, and it can send a packet to its destination. Okay, so you're going to implement sort of a simulation of that. All right, so that's my lesson for today. Oh, not quite yet. I did want to also show you. You guys are going to write your own queue class, but there is a standard Java queue class. And let's look at the method summary. Peek. Oh, it looks like they call dequeue. See how poll retrieves and removes the head of the queue? So or they call it remove. And then they have, and they call it add. So depending on its enqueue or dequeue, but the standard Java class calls it something a little different, but it does the same thing. All right, so that's my lesson for today. I hope it was enlightening, and I will see you in the Zoom.